Hey, welcome to the Healthy Enterprise, and thank you for coming back if you're a returning listener. If it's your first time, welcome. I hope you enjoy this episode. I'm going to be talking with Marc Koska. He invented the revolutionary K1 auto-disable syringe, which prevented the spread of blood-borne diseases and saved about 12 million lives. He went on to other nonprofit organizations and was eventually awarded the Officer of Order of the British Empire for his contribution to global healthcare. Today, he is the co-founder and head of product design for Apiject. So this is going to be a good episode. Let's meet Marc. Marc, thank you so much for taking the time today to join me on this episode. I'm really curious to learn more about Apiject and your journey through social entrepreneurship. So, here's the spotlight for you. Introduce yourself and explain a little bit what you've been doing over the last little while.
Okay, thanks. Well, pleasure to join you, and pleased to spend the next 3/4 of an hour with you and talk through some of the stories and learnings, and obviously open to any questions that you may have.
Absolutely, I probably will.
Good. Well, essentially, I became very interested in trying to solve problems, and long story short, I was exposed to the media onslaught of HIV back in the early 80s. HIV was identified in 1981. It was, much misunderstood. It was much maligned. It was misappropriated in lots of different ways, as the media would. And it was quite a confusing time. I suppose in a way I was kind of shocked, having grown up, well-fed and had clothes on my back, in thinking, hang on a minute, no one told me that viruses could go around the world and be spread by contact between human beings. That just didn't seem, that wasn't part of the game. Hey, no one told me that was going to happen.
Right.
And so when I sort of started understanding and saw the blame game coming out about it was either hemophiliacs or it was gay people who were spreading this, I found that kind of incredibly disturbing and uncomfortable. And I started researching, and there was, while I was researching, I was sort of trying to read everything I could. There was no internet back then. This is 1983, 84. And so you had to get everything from newspapers or the media or the odd book that was published. And there was one quote in a newspaper which said, one day syringes, the reuse of syringes would be a major transmission route for HIV. And I just thought this was an extraordinary thing to read. Number one, I was sort of, hang on a minute, no one told me that the human race would be susceptible to viruses. And secondly, who's using syringes? This must be healthcare workers. So how come healthcare workers are doing more harm than good?
Right.
That just didn't, compute to my...
Didn't make sense, Pieces.
Didn't make sense. This is crazy. I mean, obviously I knew that atrocities happened all the time, but on a general basis of healthcare, this just seemed ridiculous. And sadly, after doing lots of research, I found out, and this was research in the library, I found out that it was actually true, and there were recorded cases of diseases being spread. 1930, there was a huge outbreak of malaria in the British Army because in getting quinine injections, they used the same injection on 500 different soldiers, and they all contracted malaria. So, there's sort of penny starts to drop that this prediction about syringes was, wow, what do they know that, no one else was recognizing? And it took quite a while to find enough evidence, and sadly there was a lot of evidence, that, syringes were regularly reused. And when you look at the numbers, it's sort of, one syringe is used on average 3 times, I think is the current number. And back then it was a little bit worse. So it starts to make sense. Well, if every syringe is used 3 or 4 times, what can we do about this? Is this an education problem? Is this a money problem? Is this a design problem? And it's kind of a combination of all three,
Yeah, I
it
was going to
turns
say it's
out.
probably all of the above, right? Yeah.
Yeah, and probably 20 other factors.
Yeah.
And there was, you know, a big point towards, well, we need a syringe that, a bit like a safety belt in a car, stops someone crashing the syringe several times into humans.
Yeah.
And so, you know, was there a way of making it auto-disable became the term that was used. So I learned all I could. I didn't know anything about syringes. And as you referenced earlier, my hair was a lot longer back then. And I started researching and found out that, you know, there was a lot to learn. The syringe, a humble product, a most ubiquitously used product, but a very humble product, actually was much more complicated than it looked. And so I started learning about where plastic was refined from and how it was refined and whether there was a chance of making it biodegradable. Funnily enough, early on, you would show someone a prototype of a syringe that you could only use once and therefore would be safe. And their retort would be, is it biodegradable? Because even back in the 80s, you know, there was an awareness that plastics weren't particularly friendly. And so in learning where plastics come from to where the machinery is made, how do they make the machinery that makes syringes? How are actually syringes made when the machinery is installed? What regulations do they fall under? What's the economics? Who makes good syringes? Who makes bad? Who makes expensive? Who makes less expensive? And how are they distributed? And how are they used? And how are they recycled? So I went on a 3-year quest of trying to learn every part of the story. And at the end of that 3 years, I woke up one morning and it was absolutely clear to me that there was a very small opportunity for a design that could make a tangible difference. And the opportunity was in a mold, in the plastic injection mold that are used to make the syringes. They were all constructed in the same way. There's around 600 factories making syringes in the world. They all have many molds making these, so there are several thousand of these. So you couldn't expect the whole industry to throw out their molds and start again, because they're incredibly high cost and they last a long time. So what was the conversion opportunity? And there was a very small construction line in every single mold in exactly the same place. So I took the opportunity of opening up the mold, taking off 2 millimeters of metal and putting in my 2 millimeters of metal, which had a shape which allowed a mechanical valve to be introduced into the product. And that meant that you could use it normally once, and then you couldn't use it again. It would lock and break. This syringe was named K1 after my surname, and one for one use. And after many, many years, 17 years after reading that newspaper article, sold the first one to UNICEF. And since then, we've gone on to sell around 23, 24 billion of them around the world, mainly for immunization, and pretty much all of them in the developing world, across about 100 countries. And of course, you know, that syringe has had a big effect in lots of different ways, not just physically, but also in education and social terms. It's had a huge effect. And it's still being made today, even though the patents have expired and there's no more royalty, benefit from them.
And all these other organizations that are creating syringes, these manufacturers, have they adopted that design now?
No, the only forced market is immunization. And pretty much every syringe in immunization either uses my design, which is probably the biggest selling design, either use my design or 2 or 3 others that are, you know, well known and well established and do a very good job. So there were 3 or 4 competitors in the end who sort of shared the market. You know, you were looking for microscopic advantages to sort of take more of a market share over someone else. And a lot of that was pricing, because syringes have a funny quality. Everyone knows the price of a syringe, but no one knows the price of a scalpel or a catheter, for example. And when I say everyone, I mean everyone in the industry.
In the industry,
doctors,
yeah, of course, yeah.
And they'll all, when you say, oh, this is 3.6 cents. Oh, really? I can buy them for 3.4. And it's like, okay, we'll buy them, because an added advantage of auto-disable or single use is obviously good for the patient.
Right.
But not necessarily that good for the manufacturer.
Right.
And the reason is kind of complex, but understandable once you understand. Syringes are made as a loss leader generally. People do make money, manufacturers do make money out of syringes, but what they are foremost is a brand carrier. So if the syringe is accepted and, oh, nurse, I didn't feel any pain, the nurse feels, wow, what brand is that? Oh, that's, the Pepsi brand of syringe, and other brands are available. But that's the Pepsi. Great. I'm going to buy everything Pepsi because I don't get blamed for
they make my job. They make my job easier. They make me look good as a nurse.
Exactly.
Right? That makes sense.
And so a lot of profit is loaded onto those profit margin is loaded onto those other products and not onto the syringe. Right. So your syringe is your traditional loss leader, if you like. In the market. Anyway, by the end of the patent life, 2017, we'd sold many billion. We knew that in those cases, every single injection was safe and clean and had never been used before. And secondly, we knew that healthcare workers preferred that because they couldn't be blamed or, historically, criticized. Oh, my uncle got an abscess, that must have been you type thing. And then thirdly, we had a reasonable effect on the public awareness of safe syringes against unsafe syringes. Doctor, I'd prefer that one. Well, it's more expensive. Fine, I'll have it, because they knew it was safe for them or their family members or their children. So those three things were very, very, big achievements for us. And of course, we're incredibly proud of doing that.
Oh, I bet you are. What a journey.
Oh, yeah. And then when the patents expired, we got to the end of that period and, on reflection, what am I going to do now was obviously a big question for me. And I was thinking about those three elements of, everyone was safe that we gave, but doesn't mean to say one tomorrow is going to be safe if it's a reusable, most disposable syringes are reusable. And so, it sort of really weighed on me. I wonder if we can tackle the other issues that are in the marketplace. And I had seen them all, of course, traveling to over 90 countries for work over that period of time. You get to see lots of things that your product isn't necessarily helping or providing a benefit towards. So examples, you could have a lot of drugs available in a clinic, but no syringes. So if you tied the two together, then you knew that you would have, 330 doses of drug with 330 injection devices. So therefore, there's no reason to reuse anything. One of the prime reasons for reusing it is because, as I mentioned, they're a commodity and they're not really valued in the same way that a drug is valued. A drug has much more profit associated with it, so therefore the drugs are well supplied, but the syringes aren't necessarily well supplied along with them. So I sort of thought, well, I wonder if if I could do Act Two, and if Act Two would be able to provide, first of all, safety. Second of all, availability. Would we be able to allow drugs to be more available to people who wanted them or were prescribed them and knew that that was the right thing to do? So I'll give you an example. There's oxytocin. Oxytocin is a drug given during childbirth. If the mother is losing too much blood, you can give oxytocin. It's postpartum hemorrhage. So after the baby's been born, the placenta detaches. If too much blood is lost, you can lose the mother. It's 1 liter of blood lost, and the mother is in severe danger. But with oxytocin, you can stop that bleeding, and it's 10 or 20 cents this injection. But the reason it's not given, and we lose 200,000 women or so every year at that critical point, probably the most beautiful point in their life, is because there's no healthcare provider to deliver it, to deliver that one injection. So for the sake of that fact of not enough healthcare workers, the challenge was, I wonder if we could provide a product that could actually do the job for you. So there's a condition where if you want to give a self-injection or a familial given injection. So what if mum's at the birth attendant? Because most births are unattended. But if the mum is the birth attendant and she's been briefed and she's got a birthing kit, she would know that if blood had reached a certain level of loss, that she would reach for the purple syringe and jab it in the mother's thigh, and you could save that person's life with no side effects, and it would be almost an instant result. So the way you can do that is by having a self-administered registered product. And that basically comes down to, it's got to be pre-measured. A bit like a bee sting injection, for a kid, or peanut allergy, or any of those things. Yeah. And so those can be administered by non-trained people. And so could we make oxytocin one of those? Yeah. And the way to do that is to make a pre-filled device. And that was the thought that was dominating. What else could we help with by making a better injection system? The other thing is, environmentally, glass for glass vials is a horror show. It's incredibly energy intensive. You have to heat it up multiple times to 1,000 degrees to shape it into the shape that you need for the vial and the neck and the straight tube, etc. And then cool it down and then heat it up again. And that heating process is incredible waste of energy, or it's incredible use of energy, I should say. So even though glass is cheap, it's incredibly expensive environmentally. And would there be a better way?
Quite a bit heavier too, isn't it?
Heavier
in weight, and
it's you have to treat it very delicately in transport. Of course, they're not, so they break. If one breaks in a box, you normally discard the whole box, etc., because of shards of glass. And and glass has done an amazing job over the last 150 years. Glass has probably saved humanity more times than any of us will. But it was time for a change, in my opinion. And looking around, I came across this technology that we all know, which is the technology used for eye drops. When you get a medical kit and you get those little plastic tubes, you twist off the top, and you can give yourself a couple of eye drops. And that is made by an amazing process called blow, fill, seal, or BFS. And when I investigated this, it seemed like the ideal way of moving drugs or vaccines around the world. And what in investigation, by going to the founding company, which is called Romelag in Germany, I found out that actually many people had tried over the last 30 years or so of trying to fix a needle to this product to make it into an injection device. And there were several patents and several attempts, but no one had really cracked the code. And so my deal, if you like, with Romelag was, well, look, you're the best in the world in making these little vials. I'm pretty good at needles. I know what I'm doing. I wonder if we can work together and we can make something which is suitable and fit for purpose and meets all the other criteria of lower cost, easier to manufacture, better return on investment, so that it's commercially viable and socially viable and humanitarianly much more improved over the scene that we got. So, for example, here's one of our latest prototypes. This is the BFS at the top here. It's a flexible container. You can see I'm squishing it. This is the needle hub. This is the cap. So you would remove this in the normal way. There's the needle. Put that back on just in case. And all you do to activate, you twist the product. That activates it. You remove the cap. And then just push, like you do with a syringe, 2 fingers and a thumb. You push down on the top, and that gives the injection.
Oh, interesting.
So back to our oxytocin example, you can imagine, grandpa or mum being a couple of demos with a dummy and an orange would easily be confident enough to save their granddaughter or daughter's life. And of course, many people inject themselves around the world every day.
Oh yeah,
Whether you look at
diabetics for sure.
diabetics or
Yeah,
people who've got deep vein thrombosis or et cetera, et cetera. So
and it's
it's
not the
not.
kind of it's not the kind of thing you have to actually hit the vein either, right? It's anywhere. Yeah,
No, and in fact, the majority of injections are outside the vein. They're
yeah,
either in the muscle or in the subcutaneous layers. So,
right.
and that's our target area for those sort
Yeah,
of much bigger generic type injections, and
right.
so that's what we're going for. So,
Like
to
it's so
just finish off,
small. I was surprised at how small it is, and
yeah,
but it's just a dose, so it doesn't need to be much bigger than that. Really, it's just that's
yeah,
so simple. Yeah,
there it is, and we've
there
got
it is.
all the labeling that's required is on
Yeah,
there, and it's 3 seconds to activate, and you're off, and you can't use it again. It's of course it's auto
right.
disabled, so it meets all the international standards, etc.
So
And
who?
I could keep going on. It's lower price. It's better for the environment.
Yeah,
Even though it's plastic, it's actually made with far less energy. It's well under half the price, half the environmental cost of
yeah.
a glass vial and a syringe.
Um, so who fills it with the medication, and is it done? Is it done separately? So the syringe is made somewhere else, and the base with the actual medication is in it, and then they come together, and then that's when they're packaged. Or how does that work?
Well, as I alluded to, Romalag has been around 60 years, and they are the market leader.
So they
So there are
fill
a
it.
lot of manufacturers, 200 or 300 around the world,
Right,
filling medication or saline
right.
in these type of containers. So
Okay.
our target audience are people who use Romalag equipment now. There's a
Yeah.
new generation that's just come out, which is very pharma biased. It's very much biased towards the regulatory framework that the pharmaceutical industry runs under.
Hmm.
We've made some changes to the way we would have finished the product, which is we have this word fill and finish. So
Right.
we fill the vial and then we finish it with labels, etc.
Right.
And so the whole fill and finish process we've looked at very intensely, and I would say it's a very much an AI-based system now. We've changed it quite dramatically over the last 18 months to bring it up to speed. And of course, it's highly flexible for the future,
Right.
much lower cost than was being used over the last 30 years anyway. And so, we're sort of getting ready for the next generation. So our target audience are people who like Romalag. The target audience, definitely people in lower regulatory pathways than, let's say, the US. This is certainly for introduction,
Hmm.
because they have any. In fact, the highest stringency is one of the regulators that we're dealing with now, because we feel that if we jump that hurdle, that we've jumped the majority of them in the world, which of course is we're tackling the most difficult first, but a lot of the companies that we're looking at. India, South American countries, other Asian countries, because that's where the need is. That's where the real need is for lower cost and independency, because they don't want to rely on the big boys to send them equipment like glass vials, etc. So this is a very low cost alternative that can be done, and so that's where the need sits at the
Right.
moment. Glass, as I said before, glass and syringes are doing a great job in the West. None of us really suffered in the latest COVID vaccinations, for example, for lack of syringes, that
Right.
we had enough to get through.
Yeah.
But in the developing world, that wasn't so. And so we
That's
ended
right.
up with vaccinations falling off because we didn't want people gathering. Number one, we didn't want people gathering in groups because of the spread of COVID, airborne, or any airborne virus in the future. And secondly, they were very reliant on getting, for example, crimps or stoppers that are used in the vials from developed world countries. And those just weren't taking place because that volume was being absorbed by those countries.
Right.
And so there was a lot of exposure to these weaknesses of supply chain. And so what we've got is a complete supply chain in a box, essentially. And we ship in a container, in a 20 and 40-foot containers, a pre-assembled unit, which is plugged in and run on reasonable amount of energy. It's about 5 kilowatts. And, it's an incredible system now.
Wow. Wow, this is a great story. I mean, thanks for sharing all that. I mean, you took us down. I mean, it was probably fast tracked a little bit. You took us down the road in about 20 minutes. But what I'd like to do is go back to when the first idea came up. What were you doing? Were you in this industry already, or where were you in your professional world? Were you looking for something, or like you kind of got obsessed with syringes and you heard about it through the media? What took you down that road back then?
So when I was very young, I became very interested in a career in problems, I guess.
Okay.
And that was the best way to describe it. And so for the first,
there's no shortage of those, so you gotta.
Yeah, exactly. But I needed one that tickled me. I needed one that was going to be interesting, and kind of a large scale one. I suppose I was arrogant enough to think, yeah, I want a bigger problem. Sure enough, got one. I was actually living in the Caribbean at the time when I read about HIV for the first time, and then the media it was on an American territory, so the media was very Americanized and full on for this HIV pandemic, whereas we had nothing really in the UK where I had just left. I hadn't gone to university because that's my link to my fascination for biomimicry, which I'll explain. But in reading this story about HIV, I kind of had reached a very interesting point in my life because a year or so before I'd started making models of murder scenes. I was on a pretty turbulent island at the time, St. Croix in the Virgin Islands, and I was sailing on, every weekends. I was there for the beach, and I was offered a job to make a model of an unfortunate murder scene. And of course I said, yes, I can easily make models of this to represent the scene in court and show the jury. It turned out, obviously I'd never made a model before in my life, but I, took the opportunity. And we made this model, and it was incredibly empowering to me because making with my own hands something which had such a huge effect on the jury and the case was immensely empowering. And I ended up, the case ended up being settled out of court for one of the largest out-of-court settlements in American legal history at the time.
Wow.
And it was actually only the second time a model had been used. I think the first one was dramatized in the film The Accused with Jodie Foster, the Boston barroom rape. And that was a few weeks before this happened. And one of the lawyers on St. Croix thought that he would try and get a model made and asked me. Anyway, I was very fortunate to be able to do it. And then I made this whole series of models. And while I was, looking after myself on the Caribbean, it was brilliant to actually understand that I could do things. I could take things from an idea or a real scene, do something with my hands and translate that into something that was worth tens of millions of dollars, even though the model wasn't, But it was a fascinating turning point. Yeah. And really was empowering. And then reading about the problem, it all started to, of HIV, it all started, right, this is what I'm going to study. And in fact, the moment I read that sentence, I knew that was what I was going to do for the rest of my life. And so it was a massive turning point. And then back to university, or the choice of not going to university, came from the fact that I didn't really want to go and study any of the subjects that were on offer. And of course, that's an amazingly ignorant and arrogant thing to think. But to me, none of it was going to be directly useful. Going to university for 3 years to study something just seemed like all my peers were treating it like another 3 years off, another 3 years of not working. And
Right.
it wasn't that I was desperate to work, it was that I was desperate for a mission. And
Right.
university didn't seem like a mission, apart from I would have wanted to study what is now called biomimicry. And so biomimicry with Janine Banias and Dana Baumeister was codified into the most beautiful subject, which is understanding the way that evolution has selected not only benefits to mutations for animals or plants or any living organism to survive in the environment that it finds itself in, but how to live with each other. And so there are three structures really in my view of biomimicry. One, there's copying something. So you can look at a whale's tail fin and think, wow, I wonder if we could turn that into a more efficient rudder for a boat. And you copy something about the leading edge of the tail fin. And of course, that's totally, viable. And then the other one is a process. So you might look at photosynthesis and think, oh, we could copy that mechanism in a solar panel and make the solar panel more efficient, because nature, through billions and billions of experiments and mutations and accidents, has come up with a better way to photosynthesize. So maybe that would do something for us. We could copy that. But the one that I really am fascinated with, and always have been, but just never been able to put a structure around it, is how do organisms live, if you like, here's organism A, but how does it live with and survive off the organism below it and the organism above it? Something's eating it, it's eating something. And how did those billions of experiments and mutations and accidents happen that allowed that whole structure to do? So if we're looking at, and believe you me, I know how, I am much more humble than I'm going to sound, but to look at something like this and think, well, what does this do socially? What does this do if you could distribute injectable contraception to young women who don't want to start a family because of the cultural norm is that, maybe you fall pregnant when you're 15. But what if you could empower women in a way that isn't criticized through religious bias or gender bias or familial bias? Like Grandpa says, no granddaughter of mine will ever take chemicals made in the West to interfere with nature. That you're not doing that. And of course, no one knows their situation, and it's probably to them out of their choice. But to empower a young lady to be able to say, no, I want to not have a baby for 3 years. I want to finish my education. I want to study law. I want to do that. And of course, one of the choices is that she can either not have sex or not be forced to have sex, but also maybe she could take a contraception so that even if that goes against her, that she can stay at school and she can, she can control her own destiny to some degree. And so, that interaction of a product suddenly has a layer of social benefit or disturbance or interference. And then there's one below. We're using plastics. Are plastics, in this case, worth using? Or are they killing too many dolphins that actually we've caused a bad imbalance rather than a good imbalance or a good balance? So I'm really fascinated, and actually the team that I'm lucky enough to have assembled, a multidisciplinary, not only in each role, but also in the cross-disciplinary way we work, in that we take a lot of care about coming up with, these are some of the samples behind me that we've made over the years, but to look at lots of different features, not maybe necessarily a whole product, but features, and how that feature relates to manufacturing cost. And this is what we're trying to differentiate is that, what I'm trying to differentiate is that we're not just designing a product and putting it out in the market. What we're trying to understand is the effect all the way through from the top to the bottom. And we're just this tiny little piece in the middle calling the shots, hopefully, because we are attractive to the people who pay. So instead of putting out a load of shit that doesn't actually do any good outside of the people that benefit the people that pay, we're actually having an effect that's much wider. And so that's my understanding and my own version of biomimicry. And I've been lucky enough to work with some of the founders on field courses, and it's just been amazing. Literally, some of the most amazing weeks I've ever spent with these people who can not give you the answer, but they can explain what you're seeing so that you can create your own answer. It's sort of like my core belief, I suppose. So,
wow, that's very interesting. So
very
biomimicry is an actual study now in universities. Is that
yeah, but back then you couldn't study. It wasn't codified.
No.
It wasn't a study. Now it's only taught at one university in the world, at Arizona State.
Is that right? Wow.
In its true form. Of course, there is bioengineering, and there's there are people who go, oh, a whale's tail. I will copy the surface roughness to mimic that, and that will make a faster surfboard or something.
Right.
And quite right. That's you're taking advantage of something which through billions of years has evolved, and there's nothing there that's wrong. But the true sense of the word for me is understanding these layers of interaction, and that's only taught at Arizona State. And unfortunately, it's post-grad, and because I didn't go to university, I'm not eligible, unfortunately.
But I mean, the theory and the philosophy is certainly something that can be studied. And are there books on it out there that are being written, or there are.
There are quite a few.
Yeah. That's very interesting. It's certainly something when you were explaining it about how, it's not a far stretch to understand that we can and have probably duplicated or replicated a lot of things that nature has taught us. And the more we learn and the more we understand about the laws of nature and how they work together, I think it has an impact on us because we are one of those organisms. So why wouldn't we be able to understand how we align with everything else on this planet as well? Yeah,
it's really funny. I think nature is such it's a trigger word for me, because you hear, oh, I spent the weekend in nature, and it was like, what do you think you were doing Monday to Friday?
Where else were you?
Yeah, you were in a man-made box, but that's still nature. It's kind of it's a weird definition that most people have of what nature is.
Yeah,
if it isn't green, it isn't nature.
Yeah, maybe in the wilderness is a better frame of.
Or without human-made influences or something. But yeah, it's a much maligned word, I feel.
Yeah, it's very interesting. And it's, just in the many podcasts and conversations I've had with people, regarding so many different areas in health, that all this conversation about genetics and biotechnology and all these things. I mean, the things that are being understood and being explained and used in trying to make the world a better place, trying to help other people. And that seems to be a real common thread, is that the desire is to make things better. And there's a lot of understanding and realization that some things are actually quite broken and have been for a lot of years, many decades. And there's a mission of to fix what's broken and to find new ways of doing things. So pushing the envelope, pushing and asking, why do we do it this way? Why don't we do it another way? So I find it very interesting that you, such early on, were able to kind of go, yeah, that's something, I got to find a new way to do that, because that's how change actually happens, isn't it? Is that somebody has to decide, well, I'm going to make something better out of that. And that you were inspired at that age to just sort of go out there and tackle this as a lifelong commitment is amazing. And so that's what took you down this road into social entrepreneurship. And that's you've kind of done a lot of things in that category, haven't you? You've done a few other things I was reading about you. And in fact, you got a few awards for your work as well, haven't you?
Yeah, got a few awards.
including the officer of the Order of the British Empire. Is that correct?
That is correct.
Yes. Tell me a little bit about that.
What, the award or the day or
Well,
whatever?
what you got it for, and what was the recognition?
So when we had been acknowledged for saving the first million lives through the K1 syringe, yeah, I was actually in Vietnam on a trip, and my wife called me, and we have a rule: we never call each other. So it's either really good news or really
Really
bad
bad
news if my wife
news.
calls. And she called and said, "There's a letter here from number 10 Downing Street. Do you want me to open it?" And I went, "Oh yeah, it's probably a circular, you know." And so I thought it was, just a political thing.
Sure.
And yeah, anyway, so she read out the letter, and of course, it's incredibly flattering and stuff. But it's good. Yeah, I went to the palace with my wife and two daughters. My son was quite young; he was only 2, I think. So it was about 20 years ago, and it would have been a bit of a stretch for him to go. Incredibly cold day, I remember. And yeah, it was a wonderful event. One, you meet gorgeous people who've done fascinating things,
Sure.
and they're all interesting to chat to in the warm up. And it's a bit surreal, really. You need to be pinched a few times to understand where you are, and then you file through. And Prince Charles gave me the gong, as we refer to it in the UK. And he did this funny thing. I don't know if you've seen him on TV. He does this quite
Oh
a lot.
yes. Yeah.
And
Yeah.
so
Yeah.
he said, "So tell me how your syringe works." And I went, "Well, sir, you put it." So apparently we were both doing this at the same time, which my wife was giggling about in the crowd. Yeah, it was good. And then afterwards we had a nice dinner with loads of
Wow,
friends.
very exciting. Yeah. Well, it's good to be recognized, and yeah, clearly you're super humble about it because you didn't jump right in and go, oh, and by the way, I got this award, so yeah, I had to dig it out of you. But that's very cool. Congratulations on that.
Thanks.
So you talked about, before we get close to the end here, you talked earlier that you're working with AI. So, and obviously your company is very innovative. You use a lot of technology, including when we were talking earlier, you were explaining the board behind you is kind of a journey through your development process, but you're also using 3D printing as part of your development process, right? So, kind of give us a little bit about that and explain how that came about.
Well, we use 3D printing because it's the fastest way to visualize something and hold it in your hand. And, CAD is unbelievably incredible, but, what you really want is to hold something and, feel it and see whether it fits your hand or your fingers. And so the team here have done an amazing job of, replicating ranges of things. So we can, for example, on this product where you push down with your thumb to give the injection, we've made a whole variety of these at different thicknesses, different shapes, because we can start to see what would give us the best effect
Right.
in the injection. So here's a kid's toy called Pop It, and when you push down, it inverts and goes the other way. So of course what we've done is design this so that when you push it and let go, it stays inverted, because there's a visual clue then to the user that one shouldn't be touched, or it should be disposed of because it's already been used.
Right.
So we use 3D printing as very much a development tool. The other interesting thing about AI is that we're using it for quality by design. What we're doing is, instead of having the sort of end inspection process, which is very prevalent in medical products, where you inspect the product at the end of the line for 20 features and you test it and make sure that it's up to standard. There are better ways now being led by AI, where you're basically looking at the criteria that the product was made under and saying, well, no, these conditions are all within range. And so we know that we don't have to inspect this. Of course, there are random inspections, and this actually improves quality because you're not stopping the product in the process of manufacturing. So AI is becoming more and more prevalent in the opportunities that we have. Of course, it will be standardized in a few years, but
Sure.
at the moment, the opportunities are wide and vast, and they're very exciting.
So, for people who are kind of in your shoes, kind of walking that path towards social entrepreneurship or looking into some type of innovation or inventing something unique like what you did, is there something that, along your journey where whether it was how you dealt with your challenges or how you navigated that experience, what advice would you give to somebody kind of walking your path and taking that trip?
Oh God, there are so many cliche answers to this.
Of course there is. Yeah.
Follow your passion. But
Follow your passion.
I wouldn't necessarily say that's the right answer. I think it's more about truth. If you can go and see that you can make a difference. So in my case, I've just traveled to my 95th country, and not all, most of them were for work. I think over 88 were for work.
Wow.
If you've seen it for real with your own eyes, even if you're just one person who's seen the problem and you've got a solution that will work, then the decision is a lot easier for you. But I think there's a lot of people who I'm not having a go at people who invent toasters, but the world doesn't need more toasters, to be honest. There aren't that many problems.
I've thought that exact same thing
with toasters, but there's a lot of people who want to invent just for the sake of inventing, or be a social entrepreneur just for the sake of being a social entrepreneur. But
yeah, exactly.
Actually, what it comes down to is you've got to have traveled, you've got to have seen it yourself, and then if you've got that core truth understanding of that problem, which took me at least 10 years to really understand what I was doing. If you can gain that core understanding, then you probably have the fortitude to do it. It's tough because you're changing the status quo, and
right.
You're basically saying no one should eat bacon. Let's all eat popcorn or whatever
whatever your stand is.
You're pushing a lot of mass by being any of the inventor or a social entrepreneur or a do-gooder or whatever you want to call it. But whatever you're doing, you are pushing a lot of weight, and you've got to be prepared to know that it's worth pushing. Not just, I can make a load of money, or I can do this, or I can make a difference. It's a combination of everything. We all need to make a buck, and we all need to, feel good about ourselves, and we all need to bring a team along with us. So it's based on understanding, and it's based on truth. It's not belief. Belief is, I believe my better toaster will, sell more than someone else's. But good luck. That's not what hopefully we do here. What we do is we base stuff off data, and we try and understand the data incredibly deeply and to a fine point, so that data can then be sensibly presented to people who matter, and they're normally the money makers. They're normally the commercialized end of the spectrum.
Right.
You've got to have them on board, because no one else is going to invest $100 million to build a factory.
No.
So, those are the people that you're eventually got to make sense to. And actually, they're in business to make money. They're not in business to save the world.
No. So they want a return on that investment. Yeah.
Exactly.
Yeah.
And human nature is against change.
Sure.
Change is bad for survival. So if you want to change something, it's got to be front loaded with a lot of advantages to the people that really matter to get it over the line. And that all takes understanding. That's what I meant earlier by, you got to get out there. You got to travel. You got to understand all viewpoints.
And you've probably infused this into the culture you've created around the people that you're working with. You talked about how great your team is. And so it sounds like you've infused all of these aspects and these philosophies into your team too. And
well, I hope so. They're listening at the moment. So we'll see what they think.
We'll see what they say at the pub
when we go down the pub.
Well, Marc, this has been truly awesome. I really, it's an inspiring conversation, I'm sure, for a lot of people, myself included. I really enjoyed your sharing and your openness to explain your experience and your journey through your career. It's been an amazing accomplishment. So yeah, you must be proud. So thanks very much for sharing this time with me today.
All right. Well, I appreciate it. And it was a pleasure talking to you.
Okay, well, I learned a new phrase today, biomimicry. I just checked that out. Super fascinating. I'm going to check that out a little bit more. A few takeaways from Marc around social entrepreneurship is that it requires a pushing against the status quo. So understanding the core truth of a problem takes time, and traveling and seeing problems firsthand is crucial for entrepreneurs. Having belief in a product must be backed by data, and understanding all viewpoints is essential for success. So what a great conversation today. If you want to learn more about Marc, you can find him on LinkedIn. That's Marc Koska. And you can check out Apiject at apiject.com. Thank you for listening to this episode of The Healthy Enterprise, and I hope you enjoyed it as much as I did. Please be safe and be healthy, and have a great day.